Paradoxes are scenarios where following logical steps starting from true facts leads to either illogical or false outcomes. Many of these have helped shape the understanding of math and physics we have today, while some question the very basis of our current theories. So sit back and enjoy these 10 amazing paradoxes. Even before Galileo dropped the different weighted balls from the leaning tower of Pisa, he knew that they would reach the ground at the same time by following this simple thought experiment that led to a paradox. If it was assumed that objects with more mass, that is heavier objects, fall faster than light ones, then what would the speed of both objects combined together be? As the total mass of the objects increased, the speed should be greater, but also the slower falling light ball was attached to the faster falling heavy ball, and so it should slow down the heavy ball, leading to a speed between the fast and the slow. As the new combined ball could not be both faster and slower than the initial speed of the heavy ball, the paradox led him to believe that both the heavy and the light balls would fall at the exact same speed, which indeed it did. The universe started at the Big Bang. However, for a very long time, humans thought that there were no beginnings. The universe has existed forever and will exist forever. However, the dark sky paradox was one of those thought experiments that made humans question what they knew about the universe. If the universe was truly infinite and the universe has always existed, as you look out into the night sky, you would see a bright sky where every point is brightly lit. This is because your line of sight had to at some point intersect with a star, and light would have had enough of time to reach the Earth, as the universe was supposed to be infinitely old as well. The fact that the night sky had only few stars proved that either the universe is not infinitely large, or else it did not exist forever, which we now know must be true. Zeno's paradoxes consist of various thought problems in their own paradoxical forms. One example is that of Achilles and the tortoise. In this scenario, Achilles races against a tortoise that has a head start of a few meters. As Achilles reaches the initial position of the tortoise, no matter how slow, the tortoise must still have moved a tiny bit forward, reaching a new position. By the time Achilles reaches that new position, the tortoise must have still moved just a tiny bit ahead from his previous position. As the process repeats an infinite number of times, Zeno argues that Achilles cannot possibly overtake the tortoise. Yet, we all know that overtaking a tortoise is obviously possible. Another example of a Zeno's paradox is the arrow paradox. Assuming that time can be divided infinitely, an arrow once shot cannot possibly move, as an infinitesimally small duration of time should not allow for any motion in the arrow. Adding up an infinite number of these infinitesimally small chunks of time without motion should lead to normal time with no motion at all. Yet the arrow moves. All these seemingly paradoxical situations slowly led to scientists understanding the concept of time, infinite series, and limits much better. Imagine you travel back in the past and give Einstein a book with all the derivations to the general theory of relativity. He then uses this book to publish the general theory of relativity. Later, a scientist learns his theory and writes a book, which you then go back to the past, and give to Einstein, continuing the cycle forever. Now the real paradox is, where did the theory originate from? The book was made from Einstein's publishing, which was made from the book. It's like the chicken and the egg problem. Which one came first? The theory was seemingly created from nothing. Talking about creating things from nothing, the Banach-Tarski paradox is one that exploits the properties of infinities, applying them to specific shapes and physical objects allowing you to mathematically create two exactly identical copies of an object, seemingly defying everything we know about physics. Although the math is sound, physicists argue that this form of math does not correspond to reality, as realities do not contain real infinities. However, other scientists argue that the Banach-Tarski paradox might be the solution that explains how particles can be created from energies in high-energy collisions and other such events. When stirring up a cup of tea, it seems intuitive that the leaves should move to the edges of the cup due to the presence of centrifugal forces. However, tea leaves always move towards the center of the teacup. This counterintuitive paradox was later on explained to be due to the presence of secondary currents in the liquid as it stirred. These secondary currents occur in not just teacups, but also in the Earth's atmosphere. So studying this paradox also helped understand meteorology better. The solution to this paradox was mathematically documented by Einstein while explaining the erosion of riverbanks. This process also helped in developing methods to remove red blood cells from the blood plasma, helping in medical advancements. Based off of the special theory of relativity, objects moving faster through space move slower through time. So if you were to zoom off into space on a high-speed rocket for a few years, while your twin stayed back on Earth, what would happen? In your reference frame, the Earth moved away from you, so your twin is moving, hence aging less than you. On the other hand, your twin sees you moving, and hence he sees you to be aging less than him. When the two of you meet many years later after reaching Earth, who would actually be younger than the other? Although this seems like a paradox at first, you slowly realize it isn't as you understand the intuition behind the special theory of relativity better. Through the journey, the difference in observations is purely relative, and for you to meet your twin and compare your ages, you must accelerate back towards Earth, which brings you into the general theory of relativity, and so the premise changes and you will remain younger than your twin, alleviating the paradox. One of the most important parts of physics is the conservation laws. Just as mass and energy can neither be created nor destroyed, quantum information should neither be created nor destroyed. However, in the case of black holes, that seems to get a bit convoluted. As objects enter the black hole, they can never escape. The black hole has only three properties: mass, charge, and spin. So it seems impossible to extract information about the objects that entered the black hole, leading to the destruction of information. However, various scientists believed that the quantum information of objects remained intact on the surface of the event horizon, which grew as objects entered the horizon. Even if that isn't the case, they believed that although not accessible, the information still resided within the black hole at the singularity. However, Stephen Hawking mathematically showed the presence of Hawking radiation. This showed that black holes eventually evaporated away, becoming smaller and smaller until it existed no more. The radiation, however, would solely depend on the mass of the black hole and could not carry any information about what the composition of the black hole was. Therefore, it seems like quantum information is still being erased from the universe. This only shows that there's still a lot we don't know about these massive mystery spheres. Some scientists believe that we will resolve these paradoxes as we find out a theory of everything. Based on our current understanding of the workings of stars and particularly our Sun, scientists estimate that during the younger days of the Sun, it must have been too hot for the Earth to have liquid water and stable temperatures or climates. However, geological evidence shows the sign of liquid water and stable climates even when the Sun was supposedly too hot. This shows that we still haven't figured out the true life cycle of stars and our own Sun. More evidence that we do not understand star life cycles comes from the Methuselah star, which, based on our understanding of star life cycles, might just be older than the universe, which it obviously isn't. Life as we know it requires the perfect range of temperatures, the presence of liquid water, an energy source, and a relatively stable climate with low chances of catastrophic events like major meteorite impacts or cataclysmic solar flares. Even with these requirements, there could potentially be billions of planets that satisfy these conditions and would have life on them. Apart from these, there could be life forms in ways we didn't even know were possible, hence increasing the list of possible regions that could potentially form life. Even if a tiny fraction of these planets or regions developed intelligent life, we would be seeing the universe steaming with life. But we just don't. This contradiction between the great possibilities for life and the seemingly absence of evidence is what's called the Fermi paradox. We hope that you enjoyed that compilation, and don't forget to comment down your favorite paradox or any that you want in a follow-up video that'll be coming out pretty soon. If you enjoyed these 10 paradoxes, you'll also enjoy these 10 minutes of physics facts, so do definitely check them out. Subscribing, liking, and sharing would help this channel grow, and we'd really appreciate it. Until next time, stay safe, stay curious, and keep learning.